Off the coast of southern China, a 6-lane highway does something no highway should ever do. It drives straight into the ocean, and then it disappears. Underneath the waves, it becomes something almost unbelievable. A 6.5-kilometer tunnel resting directly on the ocean floor, deep enough for the largest cargo ships on Earth to pass silently overhead. This isn't science fiction. It's real, it's finished, and it's already carrying tens of thousands of cars every single day. Engineers built it to survive a magnitude 8 earthquake, a direct hit from a super typhoon, and a full-speed collision from a 300,000-ton cargo ship. So how do you build something like this? And why did so many Western engineers doubt it was even possible? Let's break down one of the most extreme engineering feats ever attempted.
To understand why this tunnel exists, you have to understand the problem it solved. On one side of the Pearl River estuary sits Shenzhen, a city of over 17 million people. On the other side sits Zhongshan, a growing industrial hub just across the water. In a straight line, the two cities are barely 30 kilometers apart, but by road, the actual journey used to take almost 2 hours. Drivers had to loop far around the entire bay just across the water. For millions of commuters and freight trucks, that detour cost real time and real money every single day. A bridge alone couldn't fully solve the problem. This stretch of water is one of the busiest shipping lanes on the planet. Massive container ships pass through constantly, some far too tall for any ordinary bridge.
So Chinese engineers proposed something far more radical. Build bridges where you can, and where you can't, go under the sea instead. The final design became known as the Shenzhen-Zhongshan Link, a 24-kilometer corridor combining bridges, artificial islands, and an undersea tunnel. At its heart sits the tunnel itself, nearly 7 kilometers long, wide enough to carry 8 full lanes of traffic beneath the ocean. At its widest point, it stretches over 55 meters across. That makes it the widest underwater tunnel ever constructed on Earth. When engineers first proposed this project, skepticism came from every direction. Building a tunnel on land is hard enough, but building one that sinks into open ocean, on soft, unstable seabed?
Many foreign engineers openly questioned whether it could even be done. The seabed here isn't solid rock, it's soft mud, sand, and shifting sediment. One wrong calculation, and the entire tunnel could sink unevenly or crack. Chinese engineers had a bold answer to every single doubt. Instead of digging through the seabed, engineers used a completely different method. It's called the immersed-tube technique, and it starts nowhere near the ocean at all. Giant tunnel sections were built on dry land, inside massive fabrication yards. Each section weighed an almost unbelievable amount. Some individual segments weighed as much as 80,000 tons. That's heavier than some of the largest aircraft carriers ever built.
Workers reinforced each section with dense steel rebar cages, then filled them with specially designed self-compacting concrete. The goal was 0 weak points. Not one single crack could be allowed. Once complete, each massive section was floated out to sea. Specialized barges towed the enormous structures with millimeter precision. Meanwhile, divers and machines prepared the seabed below. The soft mud had to be excavated and reinforced to create a stable foundation. Engineers laid down a carefully engineered gravel foundation bed. Every inch had to be perfectly level before a single section could be placed. Then came the hardest part of all, lowering an 80,000-ton structure straight down onto the seabed. With almost 0 margin for error, engineers used advanced GPS positioning and underwater sensors to guide each piece. Every segment had to align within just centimeters of its neighbor. One by one, 32 colossal sections were placed onto the seabed, like assembling a massive underwater puzzle, piece by impossible piece. Divers sealed each connection point to keep the ocean permanently out. It took years of precision work to finally connect every section. But building the tunnel was only half the challenge. This region isn't calm. It's one of the most disaster-prone coastlines in the world. Super typhoons regularly slam into this coastline with devastating force, so the tunnel had to be built to withstand extreme storm conditions.
Engineers also had to account for something even more terrifying, a major earthquake. The structure was designed to survive a magnitude 8 earthquake without failing. That's roughly the same intensity as some of the most destructive earthquakes in history. Special flexible joints were built into the tunnel structure. These joints allow sections to shift slightly during a quake instead of shattering. On top of that, engineers had to plan for the unthinkable, a fully loaded cargo ship losing control and striking the structure directly. Vessels in this region can weigh well over 300,000 tons, so the surrounding bridges and protective structures were reinforced accordingly. Massive steel and concrete barriers now stand guard around critical points. Every possible disaster scenario was modeled, tested, and engineered against. This wasn't just construction, it was disaster-proofing on a massive scale. For years, plenty of engineers outside China doubted this project would ever work. Soft seabeds, extreme typhoons, earthquake risk, massive shipping traffic. On paper, it looked like an engineering nightmare. But piece by piece, the impossible became real. The project ultimately set more than 10 world engineering records: widest immersed tunnel ever built, longest steel shell concrete immersed tube tunnel on Earth. Even the bridge sections connected to it broke records of their own. One tower alone reaches height comparable to a 90-story skyscraper. In 2024, the project even won the George Richardson Medal, often described as the closest thing bridge engineering has to a Nobel Prize. The same doubts that once surrounded this project have largely gone silent, because the tunnel isn't just standing, it's thriving under real-world pressure. So what did all of this actually change for the people who live here? That 2-hour journey between Shenzhen and Zhongshan, it's now closer to 20 or 30 minutes. For millions of daily commuters, that's hours of their lives given back every single week. Factories and businesses on both sides of the water are now far more connected. Goods move faster, workers commute easier, entire supply chains have shifted. This tunnel isn't just a shortcut, it's an economic artery for an entire region. Nearly 90,000 vehicles now pass through this corridor every single day. For a region home to tens of millions of people, that's not a small number. It's proof that this mega project is doing exactly what it was built to do. What makes this project remarkable isn't just its size, it's the sheer scale of risk engineers were willing to take on. Earthquakes, typhoons, ship collisions, unstable seabeds. Every single threat was studied, modeled, and engineered against. And in the end, the impossible became just another highway, one that millions of people now drive through without a second thought. Most never even realize they're driving beneath the open ocean. This is what happens when engineering refuses to accept the word impossible.